Hey, why'd you guys kick me out? You're muted, James.
It auto does that for mine. It shows that you, the host, left.
Yeah, booted me.
That's what it did for me.
That's because I ended the meeting because I'm a dumbass.
I was like, man, he really didn't want to make us see anything levitate. I'm sorry.
No, I was trying to share my screen and I ended the meeting instead. All right. Okay, so where were we at? Just the opposite of creating magnetism, we could put magnets around some coils and make something ferrous in between all of that spin, right, in a certain direction depending on which way current's flowing. And that is how we spin a motor shaft. I wanted to pull up a couple more pictures here. Look at like a single phase okay, so here's a DC motor. Whoa, holy cow. What a big motor you have.
Maybe professional, please.
Okay, so this is showing fixed magnets. On the right is North Pole, left is South Pole. So think back to our loop. If we're using direct current and we're starting to create rotation on this thing where this side is coming towards us, this side is going away from us, the magnetic field is all going this way. It's going to continue to rotate until this right-hand side is straight up in front of us and the left-hand side is behind us. And we could go through the right-hand rule and prove that, but I don't care to, just believe me. It's going to turn 90 degrees and then it's going to stop because the magnetic field is the same. So how do we get that to keep rotating? Any guesses?
Centrifugal motion, I don't know.
Magic?
Yeah. Wizardry.
Witchcraft.
Gypsy tears.
A commuter.
Oh.
Commuter. Close. Commutator.
That's what it is.
Good guessing words, brother.
Close enough.
So what happens is it's kind of hard to visualize with my crappy artistic abilities here, but as soon as that thing, can you picture what I'm talking about? So if this right here starts to rotate, you end up with the left-hand side going further away from you, the right-hand side coming towards you, right? Making sense still?
Yeah.
All right, until it gets to a right angle to where this side is basically right in front of you, and then the other side is like opposite, away from you. Man, I'm so good at drawing with this new fancy tablet. You understand what I'm saying, you know? Okay, so at that point, the commutator's job is to reverse the direction of current flow, which then makes the magnetic field go this way and keeps that thing rotating. So it just reverses current flow. In this case, it's got 3 different sets of coils, so it's going to reverse current flow 3 times per rotation or every 120 degrees, keeping that thing rotating. So that's a single phase motor. 3-phase motor okay, I don't have a good picture. I'll find one. There might be one on Blackboard, but I'm actually going to do and U. So three-phase motors have three sets of windings. To demonstrate this, it's easiest to put it in a Y configuration. Okay, a Y configuration. We'll talk about delta and Y more here in a little bit, but this is a symbol for a coil. So imagine this is the inside of a motor, and this is how the windings are oriented. So with single phase, sine wave looks like this, right? Three phase looks something like this over time. So this is happening every how many seconds? For what Ameren is supplying us, how many times a second does this happen?
60.
60. So Ameren supplies us with 60 hertz, right?
Yeah.
This is, excuse my language. 60 hertz. So this setup here, from here to here, happens 60 times a second. If you can imagine this being A, B, and C phase, so we'll make I need 3 volunteers. Anthony,
I think Ballard said he'd volunteer.
Ballard,
Connor.
Connor. That's perfect. A, B, and C phase. Anthony, Ballard, and Connor. Okay. So
Well, I did.
Anthony is up here on A phase, Ballard, and C phase. So let's say, Anthony, you're the black sine wave, Ballard, you're the blue sine wave, and Connor's the red sine wave. Okay. So when this is approaching Anthony, and he's going to peak up here, you're creating the magnetism gets stronger as current. Now this is current flow, by the way. This is not voltage. So the current on Anthony's phase is rising, rising, rising until it peaks. And as that happens, depending on where these magnetic poles are, let's pretend that right now they're here. So as we're approaching Anthony, he's pulling. It's like a push-pull thing. So at this point, he's starting to peak. It peaks as he reaches right here and then starts to go back down. That's current going down. His magnetism starts to change polarity. Now he's pushing that shaft away from him. Does that make sense? At the same time he's pushing away, Ballard, who's the blue sine wave, we're starting to pull towards him, right? So Anthony's pushing away, Ballard's pulling towards him. Ballard peaks, and then after that, when he starts to go back down, Connor starts to pull towards him. So it's like a push-pull effect that happens 60 times a second. Does that make sense? So I've told people in the past, imagine that like Anthony, Ballard, and Connor each have a big hammer. Nobody's going to giggle when I say that they have a big hammer.
I was giggling at the peaking part.
Oh,
All,
all right.
all of us are hung like field mice, so
Okay. I don't know what you're talking about because this is a G-rated classroom, but get your mind out of the gutter. Just kidding. All right. So Anthony's got his big hammer, right? And let's say this is north and south pole. It's approaching him. Anthony hits it, right? Keeps it going that way, kind of like a merry-go-round. Ballard, then his sine wave peaks. He hits it with a hammer. And that's happening 60 times a second. These guys just keep doing it. So how can we reverse direction of the rotation of a three-phase motor shaft?
which two of your wires?
Any two wires is correct.
Which still doesn't make much sense to me, but
It doesn't?
I mean it does, but at the same time it's like I can just switch any of these two wires and it just flips it.
let me hopefully make it more sense to you. It might help if I color code this. So Anthony's the black sine wave, right? Come on. Anthony's black. Ballard's blue.
White.
And Connor's red. So if you look at this this sine wave, right? We're going black, red, blue, black, red, black. I guess we're going black, blue, red, black, blue, red, black, blue, red, right? So if Anthony peaks first because he's black, Ballard peaks next because he's blue, and then Connor peaks last because he's red, we are going in a clockwise direction, right? Now pick any two of these three guys. Pick them. Go.
Blue and red.
Blue and red. Okay, we're switching them.
Oh no.
Shut up. Now I gotta draw this. So if we switch any two leads, we're still being provided with power from Ameren in this format here. But at the motor, we're going to switch these two leads. In other words, we're switching Ballard and Connor. So now, what do we have here? So this is Ballard now. Son of a bitch. And this is Connor up here. We're still hitting black, blue, red time-wise from Ameren, right?
Okay, so now
way.
you're gonna go from A to B to C, so it's gonna be the
So
opposite
now,
direction.
right. So all we did was switch two of the motor leads, and we're going black Anthony to blue Ballard, right? Blue sine wave, and then to C.
Okay, that makes sense.
That's how the direction. Remember, with this three-phase sine wave, we don't have to change the direction of current. It's doing it by itself because it's alternating, right? Polarity changes with each alternation. Remember from the intro classes, this point right here is called alternation because it's switching polarity. When that happens, that's where we get the push-pull from. And we don't need a commutator in an AC motor because current is switching automatically by itself. When you switch up which phase is peaking when, then you get clockwise versus counterclockwise. Does that make sense?
Yeah.
All right. Let's take a 10-minute break because I really do have to go to the bathroom. Derek, you ready for that?
Oh yeah.
Drop a dude. All right. 10 minutes going to be
Hey,
enough time
wife.
for you, or
That should be good for me to give birth to a San Franciscan love child.
you got enough TP?
Oh, there's never enough TP, Zach.
All right. Let's take a little break. I'm going to pull out a motor and we're going to go over, somebody mentioned it before, 9-lead, 3-phase connections. High voltage, low voltage stuff. But first, I really got to go pee, so. I'll play some music for you in the meantime.
What is this?
got one for my phone. And
Try to get on laptop speakers don't work.
do you need some speakers and a mic?
It's like, yeah.
It's same here, but I used external speakers and they work. And then if you have a camera, you can use that for a mic. Yeah, this one's not hooked up. It's probably plugged in. Just unplug it.
You got speakers, you said?
I never did anything for you.
You did stuff for me. Thanks, dude.
No problem, Bob. Did I ever tell you I said that to Dad one time? Said, no problem, Bob. And he like, what's my dad have to do with anything? Like, it's just a figure of speech.
Yeah, too much in.
Yeah. No problem. Hi, guys. Can you hear me? You probably muted me, right?
No.
Because you couldn't stand that music anymore?
Lost a brain cell.
Huh?
I lost a brain cell.
Just one?
Probably all you got left, isn't it?
Well, no, he's down to two. All right. James, Jay, Jeff, Kyle, Jonathan. There's Jay.
What's up?
What does Gorth Brooks mean?
He's a famous country music singer.
Gorth?
Yeah,
All right.
he's the extra large version of Garth.
Might also be familiar with Al Gorth.
Arthur
Okay.
Cleveland.
Fill me
Or-
in. Fill me in. Where does it come from? There's got to be an inside joke here.
We're being super serial about this.
So
Super cereal.
I'm a very robust man, and rather than say girthy, I say Gorth. And now we've applied that to celebrities.
So who's Gorth Brooks? Is that me?
No, that's me, bud.
That's you?
Yep.
Because I'm robust too. So what's my name going to be?
You can be Al Gorth if you want, Zach.
I'll be Al Gorth.
You be Gorth Mall.
All right. I can dig it.
Don't forget Gorther Cleveland or hell, pulling on my neck fur.
Gorth and Ramsey.
Oh, I like that one. Who? Oh, Jeff Gorthen? Ooh, that's a new one. That's slick.
Write that down.
What was his number? 23? Just
Gorth
kidding.
Fieri.
Oh, Gorth Fieri. Yeah.
I had a really good one, but I can't say it.
Sure you can.
Do it, you won't.
Oh, because it's somebody
you
we all
got it.
know.
This is a safe place, Zach.
I could lose my job over this one.
No, it's recording, right?
Yes. That's why I'm not going to say it.
I mean, we've already had one teacher lose his job with us. So.
Who's that? Oh, the welding guy?
Hey, there was another one?
Wait a minute. Who lost his job over you guys?
Not over us, but Tyler.
Nielsen?
Yep.
You guys got rid of him?
We didn't get rid of him. He
He
left.
was a good man.
Yep. Gone but not forgotten. The great farming implement in the sky.
Hi, man. So I have a
You're muted.
What?
You're
Oh.
muted.
Was he trying to make a phone call to somebody else, it looks like?
Yeah.
Oh. You're on the phone during my class? What the All right. Somebody before mentioned 9-lead 3-phase motors or something like that. Somebody mentioned high voltage, low voltage. Who mentioned that? Okay, well, whatever. Let's talk about them anyway. Here's one. This is a 9-lead 3-phase motor because if you look in there, there's 9 leads. And I'm going to set this down and run through the connections with you. What's this thing called? Right here.
Peckerhead.
Peckerhead. That's right.
Tee.
I'm not very mature. I need to open something up.
Big dumb dipshit.
I'm going to open this one up too because we're going to go over this now. But I'll make this one due Monday. Yeah, over the weekend it's a really short assignment. So I want to overload you guys. I know how sensitive you are. Look at that, it's already due Monday. At 12:30. So be aware you have a homework assignment due Monday, along with chapter 2 is due Friday. A lot of you already have that one done. We didn't even go over chapter 1 homework, did we? Remind me we have to do that before we go.
Yeah.
Okay. I need to find this.
Hey, Zach,
Yeah.
did you hear Cody?
Nope.
Uh, So us that are at Morton, we did the chapter 2 homework already, and there was a question that we missed, something along the lines of what are how do they label the 3 phases? Three distinct windings are referred to, and we chose phase A, B, and C, and that ended up being wrong.
Yeah. I know which one you're talking about. There was also another option like T1, T2, and T3.
Yeah.
I don't remember. I remember it's a BS question, but since everybody's not done with it yet, we can't go over that homework. So bring that up to me when we go over that homework on Friday, and I'll probably just make it extra credit or something. Did you just raise your hand, Anthony? Okay. All right. I got to find this.
Wants it now.
So what is the thing called on the side of the motor that's got all the information on it? Voltage rating, horsepower, and all that stuff.
Nameplate.
Nameplate. And on the side of the nameplate, you might see a picture that looks like, wait for it,
Still waiting.
this.
Yes, sir.
What does that mean?
how you hook it up for high and low voltage.
Right. Why would you hook it up for high versus low?
Depends on what your facility has where you're hooking it up at.
Yeah. So instead of having two motors, one of them's rated for 208, the other one's rated for 480, you have a motor that can handle either one of the voltages depending on how you hook the windings up. So this one that I have with me is 208, 480, like I just said. So I'll just write that down. 208 or 480. Is that single phase or three phase?
Three.
Three phase for both, right? So the motor windings are either going to be hooked up in a delta configuration or a Y configuration. So when you open up the motor, the windings are not going to look like this. They're not going to look like this. They're going to look more like this. Okay, it doesn't look like they're configured in Y or delta or anything, but the ends of these coils are going to be configured in a way that's like Y or delta. So in a delta motor, 6, 3, and 8 are already joined internally. Okay, so this is a winding here between 3 and 6. This is a winding between 3 and 8. Those are already joined internally. On a Y, 1 and 4 are end to end, those are open. 7, 8, and 9 are all hooked together at this midpoint. So it's just how those coils are hooked together inside of the motor. Okay, it doesn't look like that when you open it up. It looks like all these big coils that don't make any sense. But let's say I have a motor that I'm going to hook up. I know it's 208, 480, but the pictures over here that show how to hook them up for Y or delta low are scratched off or rubbed off or whatever. How do I know how to hook them up? First, let's talk about this. In a Y motor, you got 1, 4, 7 in this common point. Somebody mentioned this before, but this is very important. For high voltage operation, series or parallel? What do you think?
Series.
And low voltage, you parallel, right? Why do you think that is?
Because in parallel, the voltage is shared across all the parallel branches, right?
Yeah. And think of it this way. I always think about it in terms of like voltage drop, right? So if I need that magnetism to be a certain strength in order to turn a shaft with a certain amount of torque at a certain speed, at a higher voltage, that's going to do some different stuff to that magnetic field than at a lower voltage. So if we take two coils and series them, we're going to get a different effect from a higher voltage. Think about it like voltage drop. You're going to get more of an effect across both of them put end to end than you are if they were, say, parallel. So high voltage series, low voltage parallel. That's just the way I think about it to keep them straight in my head. So you're going to need to know how to do this for your homework, and it will be probably on the quiz and the final. So let's look at high voltage Y. So these top ones are Y, the bottom ones are delta. So high voltage Y, how are we going to hook these up, series or parallel? So we're bringing in 480 to this Y wound motor. Series or parallel?
Series.
Series for high. So all we're going to do is join these windings right here, these windings right here, and these windings right here, right?
Yep.
So Y high, it looks like this. 4 to 7, 5 to 8, 6 to 9. Who giggled? You guys cracked me up. Okay. About Y low, we're going to parallel them, right? So what I always say is take this winding and bring it right next to here. So it looks like this. Right? We're going to parallel them. So 2 goes to 8. And 5 goes to middle part. Parallel this winding the same way. 1 goes to 7, 4 goes to the middle part. 3 goes to 9, 6 goes to the middle part. So on the picture, what does it look like? 1 to 7, 2 to 8, 3 to 9, 4, 5, and 6 tie together. Cool? Making sense? So this configuration is Y high. This configuration is delta low. That's not right. Y low. All right, let's look at delta high. So we're going to do this. What are we doing? It's delta high, or series or parallel? High voltage, series. Same kind of thing. 6 goes to 9, 5 to 8, 4 to 7. 4 to 7, 5 to 8, 6 to 9. What do you notice about these two? They're the same. So whether you have Y or delta wound motor, if you're using low voltage operation, they're going to be hooked up the same way. All right, delta low. What I always tell people with delta low is picture this as 3 different triangles. If I put a dotted line there, dotted line there, dotted line there. You see the 3 different triangles?
Yep.
Like this, this, and this. We're paralleling them, so take those 3 triangles and stack them on top of each other. That's how I tell people to do it. So visually, how do I do that then? If I'm taking all 3 of them and stacking them, 3 is going to go to 9, 5 is going to go to 9, 6, 1, and 7 are going to get tied together. 4, 2, and 8 get tied together. Does that make sense? It looks messy, but all we did was stack those 3 triangles on top of each other. So on the diagram, it's going to look like this. 1, 6, and 7. So 1 to 7. It actually does this kind of thing on the nameplate. 2, 8, and 4. 3, 9, and 5. So this is what the nameplate would look like for a delta low. Got it? Okay. Well, I want to do an example of this. Using a real motor. So we won't look at the nameplate. We'll just take the wires and hook them up however we choose. Um, come on. So I got this motor. I got a pecker head. I got these 9 wires sticking out, right?
Right tool for the right job.
And you're going to see me hook these up with wire nuts, which is absolutely a horrible way to do it. You don't ever want to do it. I don't think any of your employers would let you do it that way. What you actually do to hook up a motor is put ring terminals on them. You guys know what ring terminals are? And then you bolt the ring terminals together and then dog ball the shit out of it with mastic and 133C, 130C, all that good stuff.
You're doing it the Outcast way right now, Tech.
The all cast way?
Yep.
Hey, wire nuts will make it spin, but it'd probably eventually start a fire in that pecker head. Maybe. So
I
which
hate it
one
when
do you
my
work
pecker
for
head
all
gets all
cast?
fired up.
What?
Yeah, we definitely log everything.
I said I hate it when my pecker head gets all fired up.
I know it. So on a nameplate, you're going to have this showing you how to do this anyway. But I'm going to ignore this right now. We're just going to pick a configuration and hook it up so everybody understands. Also, that's one thing that I didn't cover, I guess, is on these pictures, where's 1, 2, and 3 going? That's your 3 lines coming in, right?
The motor starter.
Yeah, from the motor starter. We got 3 phase coming in, right? A, B, C, T1, T2, T3, whatever you want to call them. So our wires coming in are going like this: 1, 2, 3. So let's just pick delta low for this example. And you guys, can you see both the screens okay? Like my camera and the delta low. I'm going to zoom in the best I can so you can see the numbers. Can you read the numbers that are on the side of the wires?
Yep.
Cool. All right, so my 3 wires coming in from the motor starter, I'm going to use black, red, blue. So if I have 3-phase low voltage, you would guess that these are the colors being used. 3-phase high voltage, if it was 480, should I have black, red, and blue coming into this thing? What colors should I have?
Brown, orange, yellow.
Perfect, very good. All right, so I got black, red, blue coming in. We'll say black is line 1. We're hooking them up delta low. So what are we going to connect here? Got line 1 coming in. What should I do with it?
Connected to 7 and 6, I think.
Perfect.
Yeah.
So 1, 7, 6. 1, 7, and 6. I'm not going to do this very neat or very proper. I just want to get them sticking together somehow. Okay, so there's line 1 coming in. It's about to fall out. It did. Did you get the idea? Piss me off. Okay, line 2, red.
4, 8, and 2.
2, 8, and 4. 4, 2, 8. And what's left?
3, 9, 5.
And that's exactly what I have left. Isn't that awesome?
Holy cow.
Love it when a plan comes together.
How is that grounded?
Hmm?
Is it properly grounded?
Not yet. I will properly ground it here in a second. Touch this to the. There we go. Properly grounded. All right. I just wanted to do that so you guys could see, because a lot of times I've taught this in the past where I'm just showing you how to make the connections with delta Y and delta low. And it's like, well, why the hell are we making pictures of this? Well, that's how we're actually hooking it up in here. Keep in mind, though, please don't ever just use wire nuts in a peckerhead. If I hook these 3 up to 208, I can get it in the picture. If I hook these 3 up to 208, it'll spin that motor, you know, but that's not how we do it. Other instructors will actually go through a demonstration of how to hook the ring terminals up and bolt them together and put mastic tape on, put 33 on the outside of that.
Hey, Zach.
Yes.
So how do you know which way that motor's going to spin?
You don't. That's the fun part.
Isn't there a thing on the front that shows like an arrow for rotation on some of them?
No. Do you know why?
Because every application's different.
That motor, let me zoom out. Whoa. So ball door, this manufacturer has no idea what orientation Ameren is bringing in the phases into your facility, right?
Okay.
Can't guess. So if we're hooking this up to a pump or a fan, what you would have to do is hook it up, check the rotation, and if it's correct, then you're good.
Swap your 2 wires.
If not, then yeah, you switch 2 leads and off you go. It's a good question, though. All right, everybody comfortable enough with that you can tackle that homework assignment? Okie dokie. Well, I think we should take a look at motor starters, and then we should call it a day. Everybody hip
Sounds
to
good,
that?
boss.
Let me go grab a couple. Be right back.
Derek is
Jeopardy music?
No, thank you.
that looks like the exact same motor we use for all the exhaust fans,
I
wire
think
nuts
it's
and everything.
it's a ball door, so
That's what we used to.
yeah.
But we always use wire nuts at work.
Probably pretty
I do.
universal
Wiring nuts and a lot of electrical tape.
Wait, you use electrical tape? I'm just kidding.
We definitely just wire nut everything at work, though.
We do too. But we put electrical tape over it. The wire.
I mean, we do that if we're feeling,
Risky.
Yeah.
Oh, is that what Randy's been showing you?
Randy does not. Randy shows me how to sit on a bucket for 6 hours a night and smoke 8 packs of cigarettes and drink 2 fucking 12 packs of Diet Coke.
Yeah, and I came in to clean furnaces. He like kind of cornered me there for about a half hour. I'm like, well, I'm still getting paid overtime, so I guess this isn't bad.
Yeah. Hey, we're going in on Saturday, right?
Yeah.
Do you know how to bleed the hydraulic lines?
Oh, for whatever machine we got to replace it on like 3 of them.
Yeah. Well, we have to do the fluid, which I've done before, but I've never bled the actual lines completely. And Zach wants us to bleed the lines because there's a shit ton. There's probably about a quarter of what's in the tank just in the lines of some of those machines, depending on how far the run is. So I don't know how to bleed those lines. So I might talk to Zach tomorrow or today. Call him.
I mean, is he wanting us to use that little skimmer? Was that what he was saying? Have you seen that skimmer?
No, I'm not talking about. I'm talking about actually. So once you drain the entire tank, there's still a shit ton of fluid left in the lines that are running to the machine. He wants us to bleed the lines as well, so the fluid out of those hydraulic hoses.
I know. Well, what we did, cut them. That's all you do. Don't worry about the pressure. No.
Just cut the lines, bud.
Yeah, just cut them, let it leak out, and weld it back
Drain the
together.
reservoir.
What we did last time was, I mean, after we put the new fluid in, ran it, the old fluid came in, and it's all floating at the top.
Oh, and then you guys skimmed it?
Yeah, it's a little automatic skimmer. It's crazy. It's just a little tiny motor with a little...
I've seen that. I thought that was just separating the 2 mixed fluids, but I guess that worked for getting the dirty shit out of the... See, that's not going to get the particulate out, though. That's just going to separate the oil based hydraulic oil from the water-based stuff we have now.
I don't know. We'll have to ask him. He's going to be there, right?
He should be.
Okay.
Wait, on Saturday? No, it'll just be
Oh.
us. But like I said, I'll talk to him on like Thursday or Friday or something.
Okay.
Am I right? The last 2 years. That's it. Our last goodbye. I feel unhappy. I feel so sad. I have lost the best friend that I ever had. She was my woman. I love her so. But it's too late now.
You boys ready?
Her go.
I'm going to change it.
Changes in my life.
So I had to get that little thing out of the way.
Ooh. Ooh. You guys are weird.
What? What?
What?
All right, what are we doing? Showing you this. That's what we're doing. Pin video. So, this is a motor starter. Got it?
Mhm.
Class dismissed.
Woo!
Kidding. You guys used these, seen these before?
Probably.
I'm gonna.
I'm aware of their existence.
I'm gonna hang on. I'm gonna grab some tools and take this thing apart for you. Hang on.
They go click, and the motor goes. Vee!
Does it make the same noise when it goes in reverse, Antoine?
Yes.
Could you please demonstrate for the class that noise again?
Wee!
That'll do.
People. Come here.
Poppy's got some more peanut butter. Come here, boy.
Come here, boy. Come here.
Butter.
Come here, boy. He's got to stretch out.
So, Chippy, how many frogs have you gone through while you've been there?
Ooh, couple hundred at least.
I think quarantines hurt the frogging.
Should have gotten
Oh.
those tadpoles while Jay had them.
Yep.
No.
Could have had a whole stockpile just, you know.
There's some
waiting.
bullfrogs. There's some decent sized ones.
A bunch at my dad's place that I've been using.
Oh, that's where you get your stock. All right, all right.
Perfect.
We're just making sure you're, you know, not worried about this during the quarantine or anything.
It's been a little hard to lie.
I heard something about Dr. Pepper being on a shortage or something, but I don't
It
know.
fucking better not be.
Team
That's
lead
right
hasn't
behind-
mentioned
That's
anything.
right behind dang old dude, Gold pt and Pussy.
Yeah, perfect.
Oh, what'd you call me, a Gorth?
You're fucking Zach.
All right. Does anybody know what this thing does?
Start stuff.
It
What?
starts motor. It's motor.
Which one?
Starts it up.
Start it and then maintain the connection to keep it started.
Yeah. Yep. Show enough. All right. Class dismissed.
Whew.
The coil sucks it in.
Coil
Changes
suck.
state
That's right. The coil
to
does suck.
allow the motor to go.
It does suck.
I've known a couple coils in my day.
Okay. Off. On.
Oh, that's pretty neat.
Yep. So, the whole point of this thing, why would we put a three-phase motor on this instead of a three-pole switch? A couple different reasons. The first one is a motor's got the potential to draw a lot of current, right? So the contacts for switching a motor on and off have to be pretty sturdy. These have a rating of 27 amp max load, max continuous load. The whole point of this, remember, break everything down to on or off. The whole point of this is to get line 1, 2, and 3 to make contact with T1, 2, and 3. So here's your black, red, blue, or brown, orange, yellow coming in. And whenever this coil gets energized, pulls in the coil gets energized, pulls it in, turns the motor on, it makes contacts with T1, T2, and T3. So normally with this thing held closed, like I just did, you would get continuity between line 1, so it says L1 right here, line 1 and T1. But there's something missing in here right here. And so I'm going to take continuity here just to show you that that's what it's doing. But this is the whole point of this, is just on. So what happens is in your control circuit, you energize this coil with 120 volts. Even if we got like a 480 volt motor here, we can control it with 120 volts here. So this coil becomes energized. We just learned about electromagnetism. That coil gets energizes, creates electromagnetism, pulls the contacts closed, and turns the motor on. Okay. quick question. Why, if this is just a coil of wire going round and round and round and round, just like that magnet that I made and showed you earlier, how come I can put 120 volts on this from there to there and it doesn't trip a breaker or blow a fuse? All it is one wire going round and round and round and comes back out on this side.
Because it's stepping down the voltage?
Nope.
No idea.
If I put 120 volts across this wire, what do you think the current would be? There's very little resistance there, right? It would be through the roof, shit ton. If I coiled it around a bunch of times like this, put 120 volts on it, current would be like, I don't know, less than an amp. How could that be?
Is it because of the inductive reactance?
Inductive reactance. Who said that?
Ow.
Al?
Ow!
I didn't see you guys anymore. Well, whoever said that, thank you. Yeah, that's exactly right. So remember in 133 when you were learning about all that fun capacitive reactance and all that crap, inductive reactance? Kind of neat, huh?
Yeah.
Now we're using it. Now we're using it to switch a motor on and off. Okay. That was just a quick little, I wanted you to know that there was actually a reason you were learning all those formulas and stuff. So anyway, I energize this coil, closes the contacts between here and here. The other thing that this thing has special is something called an overload heater. That's this guy right here. This thing gets bolted. Right now, I don't have contact between L1 and T1 because there's no overload in there. That's this thing. And these come in all different kinds of ratings. This one's a W35. I actually have no idea what that means, but yeah, I could look it up. What this is a little spring. You can see that in there. So this is an overload heater. This spring becomes under tension when it heats up. It will unwind itself and trip. You can see inside there, there's a little bitty tab inside of there, okay? And when that trips, it breaks contact between these 2 points. So the only thing, this job is to protect the motor windings, right? So if this thing gets too hot, it's saying, hey, this motor is getting overloaded. We need to open up. And then this, if it trips, this reset button will reset it. And then this is a nice NEMA motor starter. It's got a little trip window in there so you can see if it's tripped. And if a motor does overheat, whether the bearings are going bad or it's just you put too much load on it for too long a time and this thing trips, you might not be able to reset it all the way because it's temperature, right? This thing has to cool off before you can reset it. So just in case you ever see one of those in the field and it's tripped, you might have to give it some time to cool off before you can reset it.
I heard you can just spit on it, Zach, and that'll.
You can spit on it, you can piss on it. Sometimes that works.
How long does it take those to cool down, just in like retrospect?
I don't know. A few minutes.
Okay. I didn't know if it was like waiting like a half an hour for this some bitch to cool off.
Yeah.
Depends on how big a loogie.
Yeah. Depends on how bad you got to piss. Okay, so that's a motor starter. I will take this thing apart. I've already got it somewhat apart anyway, but just so you can see, the thing I love about NEMA versus, we'll talk about IEC motor starters. This is NEMA. So NEMA is big, heavy duty, American type.
Yeah.
America. Here's America. The thing I love about NEMA stuff is that if this coil goes bad, you can replace it. If this goes bad, you can replace it. If the overloads go bad, you can replace it.
You don't have to buy a whole new freaking
Right.
$300, $400, $500.
Exactly. So IEC, most of that stuff does not work that way. You got to replace the whole unit. It's smaller, it's cheaper, it's made out of plastic, but you you can't service them. So anyway, you open this thing up and I'll show you where this thing gets out of here. So here's one part of the coil. The coil on this one is actually like a figure 8, okay? And then the ferrous, the iron core sits around it like that. The other part is this on and off part. That's the other part of the iron core. So you can see how when this figure 8 thing gets energized, it will suck that iron together, right? It magnetizes it and goes bloop, and then you see it on in the window. That's how that coil works.
That's pretty neat.
And yeah, this is rated for 120 volts. Just a 120 volt coil. And these things draw very little current. It's probably less than an amp. So you're using less than an amp of current to control a big giant motor circuit, right? It's the advantage of using a motor starter. And that's really all you need to know about motor starters. One piece that's not on here is something called an auxiliary contact, which when we start talking about start-stop stations, they have normally open or normally closed sets of contacts that, there's one on this other starter that I'll show you. You use those normally open contacts, and when this gets energized, it keeps it closed until you hit the stop button. But, what else? Show you one more starter, and then we'll be done. That was a motor starter. This is another motor starter, but there's 2 of them. Why would that be?
Forward and reverse.
Forward and reverse, very good. Exact same setup, exact same mechanisms. One set of overloads because you're only protecting one motor, but you're using 2 different coils for forward and reverse direction. And how do we change the direction?
Swapping wires.
Swap 2 of the leads. So what you do with these is you bring in your A, B, C phase, boom, 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 right? But if you energize this coil, it changes the direction. How it does that is these little tabs back here. So you can see on these lugs, all I'm doing is flipping this up so you can see the top. These are, the lugs are up front, but the part that connects the 2 starters together are back here. And you can see on this, let's see if you can see that. Yeah, you should be able to. But what happens here is this phase A is connected to phase C over here. B stays the same, and then phase C over here is connected to phase A on this side. So it's switching 2 of the leads. It's switching A phase and C phase. So if you energize this coil, it'll spin the motor down here, let's say in clockwise direction. If you energize this coil, it will spin the motor in counterclockwise direction. See how that works? These tabs reversing 2 of the leads. Exact same setup. These are the auxiliary contacts that I was talking about. So if I change the state of this coil, how these work is there's a little tab. I'll show you some that aren't hooked up, but inside here where you can't see it, there's a tab that when that coil pulls in, changes the state. This little doohickey on the side actually pulls that tab up and changes the state of the contact. So when the coil energizes, this becomes closed and this opens up. So you could have all sorts of stuff. You can use them for holding contacts. You can turn a light on whenever the motor's on, whatever you want to do. That's why they're called auxiliary. 10-4?
Good, buddy.
All right. Well, you got a couple homework assignments you can work on. And anybody have any questions? Anything we covered today?
So we're not coming in this Friday, or we are coming in this Friday?
We are.
Okay.
What room are we meeting in, Zach?
AIT 217. Wait a minute, coming in? No, you're not coming to campus. We're meeting on Zoom.
Okay.
Okay.
I thought you meant do we not have class? Yeah, we do have
Oh.
class, but we'll be on Zoom.
Okay.
We won't come in to start labs until
Monday,
Wednesday. Let's say probably Wednesday.
Wednesday.
Yeah. Eventually, I want to get to a regular schedule where like a Monday lecture and then Wednesday and Friday labs kind of thing. I want that to be a typical week, but I got to get you through some of the material so we can get you plenty of labs to be working on. So when you come in, you've got multiple things you can be working on. So everybody's doing different stuff and staying 6 feet away and all that. So 10-4.
10-4.
All right. You guys have a lovely rest of your Wednesday. I'll see you Friday on here.
Hey, Zach,
What?
how long have you been teaching at ICC?
4 years.
Okay, never mind then. I didn't know if you would have had my cousin or not, but you wouldn't have. I think Steve had him.
Who's that?
Jordan Himmel.
Nope.
Okay, never mind then.
I'm sure he's a great guy.
He built his own. I'll have to show it to you sometime. He built his own auto steer function for an old ass like 1990s tractor that we had with a servo motor and a bunch of different shit.
That's cool.
Yeah, it was cool as hell. But that's something for another day.
All right. Anything else? Bye-bye.
Bye. Have a beautiful time.
Damn.
See you guys. Have a good Wednesday.
Take it easy.
Yeah.